Hey everybody, in this video we're going to be talking about meta-analysis, and we've set this up previously by doing by computing effect sizes, specifically the effect size function and the nap function. So I'm going to begin this by taking a look at these student nap interventions. Now, if you recall, earlier in the semester when you did the nap above or below, you had the option to save the results of that. And in this case, I saved this for seven students who are in a special education program. And the goal of the intervention that was done in the classroom was to help these students remain on task more. So for each of these, there was a practice evaluation done the same way you've done all semester. A nap was computed and it was saved, and then they were compiled in the same folder. I walk you through this, by the way, in the chapter I sent you. And you can see that by eyeballing these, some of these were low and some of these were quite a bit higher. Remember, the nap can vary between generally 0 and 1. So you have these aggregated, and you had to put these together manually. And I put in our script. We're going to begin by taking a mean of those naps. And we put nap ES and label. That's standard, and that won't change for anything, because as you build that file here, as you save them, save the effect sizes, all of these labels come up. And when you're asked to label it, you just give it client 1 or student 1 or whatever like that. But I gave it the label because we're going to produce a plot called the average effect size for 7 students. So when I hit run for this, you are going to see that now we have a graph that shows the average effect size, and it actually plots on here each of the effect sizes for each of the students. But now you see on the y-axis that this is not in order from 1 to 7. Rather, it's at the bottom the lowest effect size, the second lowest effect size, and so on until student 7 saw the most improvement after the introduction of the intervention. And of course, you can export this the way you would export any of the plots that we did all semester. But what we have that's quite valuable here is we have this now mean effect size that's based on that nap for each of the students. So the average effect of the intervention across these 7 students shows it to be a moderately effective intervention. So that would give us some thought that this intervention, because like I said, in real life, generally you will see, especially in the short term, moderate effectiveness. That is usually noticeable to people, whether it be your clients or some other observers. So this would give us some assurance that this intervention was useful. Now here we see that for 2 of the students, student 3 and student 5, their effect size was well below 0.66. And so for these students, it wasn't valuable, but for the remainder, it was. So that's that type of effect size. Now, if you are super lucky and all of your studies, so each of your practice evaluations, in this case, in this class, you did 1 study, your N of 1 was your client, but if meta-analyses are studies of studies, so you have, in this case, we had 7 separate studies that we aggregated. You can do any number. The next example I'm going to show you is an intervention that was developed for 14 parents. Now, with each of these 14 parents, you would have had, in order to use sort of traditional effect sizes that I'm going to illustrate next, you would have had to have no problems with autocorrelation or no significant trending in any phase. So I showed you the mean nap first because you simply don't have that restriction. But if you were sort of lucky enough in all of your studies that you were trying to aggregate didn't have that, you could use a more traditional effect size that I taught you earlier in the semester. So let's begin by just getting that data file, and I'll show you what that looks like. The beauty of that one is that you can add control variables, and I'll show you what I mean in a minute, although we won't go into the details of that here. Okay, so I'm going to get that and run it. But when you look at this, when you did the effect size function and you saved it, it created a file that had these three variables, similar to what you saw previously with the NAP. I added this support and single variable because we wanted to perhaps think about the differences between parents who were, because this is a parenting intervention in child welfare, parents who had more or less social support, or who may be single parents and not have a partner. It does go beyond the scope of this, but it's described well, I think, in the sample chapter that I gave you. And you could control for being single or social support in either of those cases. So we can begin this analysis, since we attached this, much in the same way as we did with the mean NAP, by looking at the average effect size for these 14 clients. And of course, 14 is many more. So you're going to see a graph similar to this, essentially, but with many more people. And this is going to all be the same function, mean ES, and label, because that's all generated when you save your effect sizes. And the only thing that you're going to really have to think about more seriously is how you want this graph labeled. So when I run this, now we have much more data. And of course, this is a Cohen's D, which in the effect size function is the D index. So you see anything less than 0.87 is considered a small effect. So we have, I'm going to just go up here. We have a cluster of these. I'm not sure if this guy is where that one is, but we have a whole cluster that seem not very effective. Then we have things that are more effective up to 2.67, which may be about here. And then we have something with a large effect size. The average effect across all of these 14 clients is 1.32, which falls in the category of a medium effect. And here's something, this is a great elevator speech, is you could say across these 14 clients, on average, they improved 40.77. So that's very useful. What this function is not really able to do, the way it's written, is that it doesn't account for variation within the studies themselves. And so we can use a more robust type of effect size of meta-analysis by using the meta-reg function. And what it does is it weights each study based on the variance of the effect size within each study. So I put that in here for you. It's meta-reg, ES, and V, and that's not going to change. This is not like a behavior variable and a phase variable. It's always going to be like that, because when you look over here, this ES and this V, like I said, are generated when you do that, use that effect size function initially. So I'm just going to run this. And now we have what we used to call a forest graph. And now you see the graphs in numeric order from 1 to 14. And you see confidence intervals, which give you a sense as to, we have our sample of data that we have for our client, but this gives us a 95 confidence interval on where we think the actual effect is for that client. So that tells you what that is here. So it could range from a low of 0.59 to a high of 4.88. That's a wide range, and we see that with the breadth here. The actual point estimate, the calculated effect size for this client was 2.73, and that's where that is. The other thing that you'll notice is that some of these boxes are big and some of these are small. The larger the box, the larger the sample is. So in this case, the more observations there were within each study, and so the more influential those are. And so you see study 3 is more influential. Study 14 is pretty influential, as is study 11. And you can see, again, these size of these boxes vary. This gives us the total effect size that is marked here. It's 0.94. You see that in the intercept here. And then the confidence intervals here, that the true effect that we're 95% certain that the true effect is somewhere between 0.44 and 1.44. And this is what we have observed. And again, that interpretation is similar to what we see up here because it's an aggregation of that. So 0.94 is still a medium effect. Even when we weight all these, when we weight all of these studies, it's still a medium effect, and it's statistically significant. And I hope you found this useful. I hope you consider using this in your own practice. And if you have any questions, let me know.